Welcome to this introduction to logarithms. In this lesson, you will learn the basic properties of logs and how to change an exponential equation into a logarithmic equation. So let's get started. Look at these two exponential equations. Can you solve them? In the first equation, x is equal to 2. In the second equation, y is equal to 3. Pretty simple, yes? Now let's look at one that is not so simple. What power would you raise 2 to in order to equal 6? Well, there's certainly no integer that works. We also know that the answer must be between 2 and 3. So how do you solve an equation like this? We could try to solve for the variable z by dividing both sides of the equation by 2, but that does not get z by itself. We could divide both sides by z, but clearly that does not help. Multiplying both sides or squaring both sides will not do the trick either. To solve an exponential equation for a variable, we need an entirely new function called a logarithm, or log for short. This will let us solve our equation for the exponential variable. In order for us to use the log function, we need a basic definition, and here it is. At first glance, this seems a little confusing, so let's break it down. Looking at the exponential equation, y equals b raised to the x power, notice that b is the base and x is the exponent. Now we are looking at the exact same equation rewritten in log form. This is read log base b of y equals x. It is important to read the equation exactly like that. The subscript is read base b. Now we are looking at both forms. See how the b, which is the base in the exponential form, becomes the subscript b in the log form. Also notice that the exponent x in the exponential form is now what the log equation is equal to. The log equation basically rewrites the exponential equation, but the exponent is solved for. It is important that you are able to take an equation in exponential form and change it to log form, and vice versa. So here's 3 more examples. Again, understand that these equations say exactly the same thing, but they're just written in different ways. Can you write these exponential equations in logarithmic form? Here are the answers. Now let's try going the other way by changing a log equation into exponential form. So how did you do? It's very important that you are able to change from one form to another. So now let's take a look at the original equation that we were trying to solve. 2 to the z power equals 6. Now you should be able to change this into log form, but that's not really very helpful. How do we find the value for the exponent z? We will need to use a calculator to find the value for z. The one shown here is a TI-84 Plus, but any graphing or scientific calculator will work as long as it has a log key. You probably noticed that there's no base number on the log key. How then would you calculate the log base 2 of 6? In order to be able to calculate the log base 2 of 6, we will need a new property of logs called the change of base. This property is shown here. This allows us to change a base 2 logarithm to a different base logarithm. A logarithm without a base number is understood to be a base 10 logarithm. This is the base that we will use in the calculator to compute our answer. So now finally, we are set to solve this exponential equation using logarithms. The steps are shown here. Notice the use of the change of base property and how the answer is rounded to 3 places. We are using an approximation for the solution because there is no exact value for z. Checking the answer, we see that raising 2 to the 2.585 power will give an answer that is very close to 6. The solution from the calculator is an irrational number, like pi or the square root of 2, so we can only approximate the value. To summarize this lesson, we learned a new function called a logarithm, which allows us to solve for a variable which is an exponent. It is important that you know the definition of a logarithm, that you can convert from an exponential form to a log form and vice versa, and that you know the change of base property so that you can calculate the value of any base logarithm in a graphing or scientific calculator. Well, that's it for now. Stay tuned for more lessons on logarithms.